Now we conclude with the last type of media that we have, wireless media. So we have here we look at the properties, right? Properties of wireless media. Wireless media carries electromagnetic signals representing binary digits using radio or microwave frequencies. This provides the greatest mobility option. Wireless connections numbers continue to increase. Right. Wireless media, I think, is very effective, especially with the mobility that it offers. If you have your phone, you're connected to the internet, you can move. Or remote mako, you can still have a connection with your famba, communicating. That mobility, I think that is huge for wireless media. With the other types of media, if you are connected, wisa connection, Ethernet cable yako, wisa fiber cable yako per device, you cannot move with that device. Mobility is limited. That is not the case with wireless media. And I think that's the biggest factor in choosing wireless media. Right? Some of the limitations, though, coverage, effective coverage can be significantly impacted by the physical characteristics of the deployment location. Kana uri mzvimbo in a lot of distractions, a lot of buildings, tall buildings, a lot of mountains, a lot of obstructions. Wireless media cannot be a choice. Why? Because signal rako it gets blocked. If I can simplify it, it gets blocked. Kana uri mugomo, for example. That's why my base stations, I'm not my booster. They are usually put at the top of the mountain so that we get access to, we don't have obstructions. We have that line of sight to the booster in, right? Nzvimbo rakaiswa mugomo, nzvimbo dzinenge dziri munomu, for example, tomboti this is our mountain, this is our boost. Nzvimbo dzinenge dziri muzasi munomu, network inenge yakadhakwa imomo. It's because of the environment, right? The physical characteristics of the deployment location. So that's one of the limitations, the wireless. But kana iri fiber, tinoifambisa nemugomo imomo inosvika apa, toidai, yokwira mugomo ichidzika ichiita sei. But wireless signals can be a bit tricky. Base station rakaiswa panapa, nzvimbo dziri muzasi meso umo will probably be experiencing some challenges connecting to the network. Then interference, wireless is susceptible to interference and can be disrupted by many common devices. Because of my frequencies, anoshandiswa. So for example, wireless LAN, Wi-Fi, it mainly uses these frequencies, 2.4, 5 gigahertz, these bands. So kana pane mamwe devices anoshandisa these frequency bands, they will easily interfere with signal connection yako. Because we also have my devices which use also these same frequencies. So they can easily interfere. We have them, a lot of them. So they can easily interfere with your signal. That's another problem here. Wireless type of media. Never a problem in fiber. Never. Security. Wireless communication coverage requires no access to a physical strand or of media, so anyone can gain access to the transmission. Right. Traffic kana richinzi irikufambira mumhepo, that is wireless. Irikufamba mumhepo. It means anyone has access to it. Of course, anyone in courts, it's not anyone who has access to it. But the guys who need that information, if they need it, they will get it. Because the information, most of the information at now, no one needs it. So it's not a huge problem. But security-wise, let's say a company which moves a lot of money, my transactions, a bank, they're getting moved. More than hotspots. Yamaha on top of that. That traffic can easily be intercepted wakomana vanoita basa nayo. So security wise, wireless communication is not that secure. Shared medium, I think I mentioned this already. Wireless wireless lines, wireless media operates using shared medium. Meaning, can actually send the information. If one device wants to send information, I think the example I gave, I used the bus topology. It's almost the same in Wi-Fi. Can also send the information, you have to test, check if the medium is active. Pana send can person send then you can actually send some information. That's how the shared medium concepts works. And wireless LAN uses a shared medium. So those are some of the limitations that we have. But I think the big W for wireless media is the mobility that it offers. It also offers a great number per bandwidth. In a bandwidth, it's okay. But I think the biggest factor in the mobility, it allows us to be mobile. Right. Types of wireless media. The IEEE and telecommunications industry standards for wireless data communications cover both the data link and physical layers. In each of these standards, physical layer specifications detect data and radio encoding methods, frequency, and power of transmission, signal reception, decoding requirements, antenna design construction. I think we've touched on this already. If you're not forgetting, we're discussing the physical layer. And I think in the last few slides, we were talking about media. And media is part of the physical layer, the types of media that we have. Here we are getting reminded again, the physical layer, it has standards. Those standards define the radio signal encoding methods that we use, the frequencies that we are going to use, the power of transmission, how is the signal being received, how it is being decoded, how it is being encoded. Okay, we've touched on that. The antenna design, what type of antenna are we going to be using? So those are the standards that define the physical layer. Right, wireless standards. Wireless standards, we have your Wi-Fi. This is your Wi-Fi there. IEEE 802.11. This is your Bluetooth wireless personal area network 802.15. This is your Zigbee. For my undergrad, I did in a project which used this technology, the Zigbee technology. It's a wireless technology, low data rate. Right, we have WiMAX. I know of Telco, which offers services, the WiMAX microwave. You can connect using my stations out, my antennas out, a microwave. That is WiMAX 802.16. That's a wireless technology that we can use. So you can see these are the types of wireless standards that we have defined by IEEE. That's the organization that defines that. Right? Wireless LAN in general. The wireless LAN requires the following devices: an access point, a wireless NIC adapter. The word I was looking for last time when I was talking about digital device connected with a USB, it's called the wireless NIC adapter. Right? So to connect my devices using the wireless media, you need an access point. You also need these wireless adapters. So if this is my device, this is my laptop, I have my NIC connected, which allows me to connect to a wireless network. Then my access point, I will have my access point, which connects wirelessly to my device via my NIC. This access point is connected probably to a switch. We call this the distribution system. Then to a router, then to the internet. This is the setup network. if you're going to design my networks on where shall connect via the access point, this is the basic design that they have. From your device to the access point, to the distribution system, to your service provider, to the internet. There are a number of wireless standards when purchasing wireless equipment, ensure compatibility and interoperability. Right. My standards are, if, for example, my standards a Wi-Fi, wireless LAN. We have 802.11. That's the general standard which represents wireless LAN. But we have my different standards in that 802.11. We have A, B, G, N, AC. I think there is also AX. Right? So you see, I don't support them. My frequencies are different. I know this one supports both. No. I know this one for a fake. Supports both 2.4 and 5 gigahertz. These ones, the earliest ones, they only support 2.4. I think this one should support only 5 gigahertz. So in terms of compatibility, if PC yako ichisupport only 2.4 gigahertz, unotenga access point rinosupporta only 5 gigahertz. Compatibility wise, that's a problem. So you won't be able to have efficient communication there. So there are a number of wireless LAN standards. When purchasing equipment, ensure compatibility and interoperability. Kana standards wa akasiyana, it will be difficult for you to configure a functional network. Administrators must develop and apply stringent security policies and processes to protect wireless LANs from unauthorized access and damage. Right. I already mentioned one of my limitations in my wireless LAN is near the security because the signal irimo mempo. When we are using fiber, signal ringa rimko. Signal ringa rimko no. For you to get access to this signal, you go to chadambra that core. But the moment you're not dambra that core, we no longer have a signal being transmitted. So security-wise, fiber proper. But with wireless LAN, we don't have that. With wireless LAN, that's a problem. Eban. Okay, with wireless LAN, that's a problem. So there is a need for having strict security policies so that you protect information that you transmit over the wireless LAN. I think we'll discuss security, wireless LANs in general. It's in CCNA too. How do you design a wireless LAN or wireless local area network? And voila, we are done. So that summarizes the topic that we have, the module that we have, yeah, the physical layer. And I think basically what you need to know about the physical layer, that is where all the physical devices are. That is where all the cabling is. That is where all the transmission happens, all the encoding, all the electrical signals, all the optical fibers, all the copper cabling, the UTPs, the STPs, the coaxial cables. That is where everything is. And I think we're good for the day. Any questions before we close this one? Questions? None? Okay.
Sorry, ini ndadatongobvunza kuti tiri kuita online like ina mbezini kweru amene
Yeah.
kuti malabs tingazouya kana kuti zvarini kana kuti tingaita sei panyaya dzephysical networking.
Okay. Let me respond that